to our next session of the day. It is a pleasure to introduce Dr. Soumen, the head of analytics at Hindustan Coca-Cola Beverages. Soumen comes with over 20 years of experience in analytics and currently working as head of analytics at Hindustan Coca-Cola Beverages. Previously, he has worked with EY, Mountain Systems, TCS, and Symphony in various leading roles. Today, Dr. Soumen will talk to us about GenAI and recommendation engine, a super topical subject that will cover how GenAI recommendation engines create recommendations by generating new content or items based on the user's preferences and historical interactions. So let us all together welcome Dr. Soumen Ray.
Hello everybody. It's audible? Yes. Fantastic. I think it's a Saturday evening, not evening I think. Yeah. It's afternoon. I think Viral has done a fantastic presentation. Thanks Viral. Thank you. It's really good presentation. I have seen long time. Yeah. Now I'll go a little bit different. I think it's more technical and I'll go with the business context, how we are going to use the GenAI. Yes, I understand. Yeah, sorry. GenAI and how it will be useful for our current business context. So I'll start with a I'll just start with one kind of a statutory thing that this is my personal view. It is nothing to do with ACCB and it is not stating any views that the company is having. Okay. Now I'll start it with a small question that how many are using recommendation engine today in this room? I think very few, right? And how many started? I started recommendation engine almost I think around 16, 17 years back for one of the US clients, and that time it was very new in India. And preliminary I started reading it, and it was very interesting story that how the first recommendation engine is actually impacted the business. Okay, and the story started with a peculiar thing that somebody gone to store and started purchasing diaper, and essentially what has happened with the diaper they also picked up beer. And when it started happening in different grocery store, then they tried to capture that behavior, and whenever business started to capture that behavior, they wanted to monetize it. They go into that depth and started thinking that do I know the customer who is going to buy this kind of two products together, when they are buying, how much they are buying, and if I capitalize this two association or two recommendation together, how much the monetary benefit I am going to get it. So started the journey that way, and if you just see that they started analyzing and they see that the age of the gender of that obviously men, and there is a 30 to 40 years in age, and typically the Friday they are going in the store and they are buying diaper with that beer. Okay, the story is very simple. The Friday evening generally the spouse goes for the party and they stay back and take care of their kid. Usually all 5 days actually she is taking care, and now we need to do our own part. So that's the way it started, and they while doing that they also have beer. And whenever they have done this two association and two recommendation, they actually done a very small thing. That time all these were very old, that online and everything. And whenever they put the beer next to the diaper, and they see that 35% increase in sales of both the thing. Okay, because they don't have to search for the goods which is very associated together. So this is one of the grocery store has done it. Now I'll go a little bit deeper that how difficult today is. Okay. Now I'll start with simple thing that now if I consider our customer, and probably everybody goes to online store and they have seen that certain things are recommended in the Amazon or Flipkart and everywhere, but it is so easy to see that, but it is very difficult into the actual business context. I'll go into certain depth and that how difficult it is. So if you see the customer 1, 2, 3 or many, they started buying certain items, okay. And also there are items which has different rank ordering. Rank ordering, I think probably everybody understand now. So they are going to buy in a different rank order. So suppose I say that I am going to buy maybe pizza today, and after 1 hour I will go for maybe Coke or something, some soft drinks or something like that. I will go for ice cream after that. That is called kind of a ranking. I am going to do that. And whenever we are doing these two association together, then I will get a kind of a customer cost product matrix. And that is a basic recommendation engine that we have. And we can use some kind of a priori market basket analysis and everything together. Then after we are having this small business context, what started happening is that things are getting complex. So I was working one of the apparel or manufacturer. What actually happened that how do you know that one guy is going to buy a shirt which has a certain collar, certain type, certain color? He is not going to buy same shirt together again. So the customer preference is going to change with the time. They are not going to buy second time the same products again and again. So that's the whole crux of the problem, that if he is not buying the same product, how can I know that customer's behavior second time? I have to associate that customer attributes with the other attributes of the another customer and started seeing that customer's behavior. So the whole thing started like that, and there are different models, probably collaborative filtering. I think probably everybody has used it, collaborative filtering, which is cos theta and which is a cross product, started like that. And whenever we have generated the association, and both we will do the recommendation engine. This is the basic way that we started the journey. And after that, whenever I started doing that, the problem started is that I don't know the product importance of the product attributes, because I know this probably this microphone is there, it's very good, but I don't know that what color you are going to prefer. The black color is good or the white color is good or red color is good, we don't know at all, right? So then I started working on a different aspect called recommendation engine attached with the conjoint analysis. Probably conjoint analysis we also have seen, and that I have done it little differently. We started with the attribute preference of the products, and attributes can be anything like your color of the product, your price of the product, your brand, everything. And with the conjoint analysis, I will try to find out that what are the importance parameters I am going to consider, and on that basis we are trying to use the recommendation engine to have kind of a recommendation which is attribute based and also the customer based. Now this is very simple. I think so far we are talking about very simple thing, and everybody is very happy. Yes, we have done it in past. But what is the fundamental problem? If I go back to this whole analysis, see what is actually happening is that we are having this matrix for a year or two, and we are doing a priori or certain kind of algorithm, we have used it. It is a fundamentally we are doing. Now when we have started doing it, what is actually happening? We are missing out the customer behavior change in a certain way. So I will just go it little bit depth. So suppose I consider this matrix today. Month 1, this customer buy nothing. Month 2, he bought one product from item 1, and again he doesn't bought anything. Now this way, if I say that this all months are there, and whenever we are doing a recommendation engine, what are we going to do? We are going to take all that together and run collaborative filtering and everything. But we are going to miss the month-wise behavioral change of this customer, and that is the complexity I am talking about. I don't know whether anybody has faced this kind of issue or not in the practical thing, but in a business context, every time we face, because every time you are going to change. Now, how do I capture this? Any algorithm you think through? Obviously, we start thinking that time series algorithm, right, everybody? But yeah, so time series algorithm will not solve the problem, because this is a kind of a network problem. So, kind of you can say that I will go to this beer story and probably you understand this. This is a random walk, right? I am doing a random walk kind of a thing, and I do not know actually what is the final destination. Maybe after I drank a lot of 4-5 peg, I want to reach the home. I done all the things, but I have not reached the home. I reached the neighborhood house, right? And next day I have a different story altogether. So this is essentially is a random walk we are going to capture in the whole story. Whenever we are doing that, suppose I start with A. Okay, I am going little depth on that, how we are going to do that. Start with A, then I will reach either H or B, right? But I can go to F. If I go F, then I will get further path. But if I go here, then I do not have any path. I will just end with the path. Then I will go further path D, E and G. So if I go directly A to F to G, or I can go this way. So I am talking all this context about your your behavior of the change of the month. So I will give a correct context here that whenever you see that certain business context is changing, like the growth of the business is 30%, but I do not know where from the growth is coming. And whenever I am talking about the 10 years down the line and predictive, that when I am going to reach G, whether my business will behave the same way or not. It is as good as that. So whenever we are doing the random walk, little bit I am going in a different. So what is going to happen? So all this path essentially is your probability of occurrence. Okay, and if we are going each one of the probability of our occurrence, and whenever you are reaching there, that is your final destination. So all this probability of occurrence, if I just talk about that, the likelihood you are going to touch each node, we are going to calculate this way, and this is your final likelihood, that the final destination I am talking about. So each one has your own likelihood to reach. Now this whole thing we use in a different way called graph embedding. Graph embedding is not a very new topic, but obviously it's invented and started using this way because of the complexity of your memory space. Because whenever I can try to run in graph embedding in my laptop, it is difficult because I have to capture all this random walk and the probability, and I have to go into that kind of a final destination. So this all graph, if you see, gradually is moving one to here, one to here, one to each one of is going to do that. This is also called deep walk. Now I'll go. I think this is everybody is more probably has a computer science background, more or less, and they understand that BFS and DFS. So this is the same methodology, but we are using in a different context. Like collaborative filtering, we have learned in our childhood, maybe 20-30 years back as a cross product. But whenever we do cos theta equal to all this, then we realize that we learned it, but we have not used it this way, right? It's the same way that we learned everything in BFS and DFS, but we have not used in the recommendation context, which we started using it recently. Okay. And BFS, a little bit context is that in the BFS algorithm, whenever we are not considering the depth, we are just considering the breadth. So from U we can go S2, S1 or S3, but if I go there, the breadth of going to this is not there. So whenever I am considering BFS, it can go here, and considering if DFS, I will go destination. Why I am talking about this, let me give you little context about little beverage industry about China. China was very good in certain particular category, which completely changed, and they moved to tea and water category after 15 years. So if we could have predict that time, then probably we reach our destination very fast for the industry, rather than they are stuck on the same category whatever they started selling. The same thing I am talking about. Now there is another thing, structural deep network embedding. So Now we are all talking about the this graph based kind of a network. Okay, graph is changing. But if I just consider this graph, the only problem is that each one is associated with one node, then only they are going to change, right? But if I consider the whole structure, like suppose I say that everybody is in this room is going to behave in a same way, in a different structural way, then how we are going to do that? Then probably we are going to hit the ground on the structural deep network embedding. Now, interesting thing, so far you see that mostly we are doing unsupervised learning and unsupervised deep work and all this thing. This one has two parts. One is supervised, another is unsupervised. Supervised, what is going to happen is that we are going to see that what is our neighborhood structure. Means if I go supervised in this way, we can reach from here to here, here to here and here to here. That is called neighborhood structure. It is not considering the ultimate or destination that way. So these two actually, first one will be your neighborhood structure, which is mostly supervised, and then unsupervised or second order destination is that they are going to understand that whole structure and global optima, and they are going to move towards the global optima. Okay. Suppose I will give one example, like one of the industry started selling cookies, okay, but they are not able to realize that people are moving towards the millet cookies, okay, and they always see that everybody in the neighborhood, they are selling cookies and they are packaging nicely, they started packaging nicely, but never focus on the millet cookie. Like your Kodak, they are very good in camera and everything, but they never focus on the digital camera and they are out of the market. So you are not seeing the digital, this global optima, rather than you are just focusing on certain aspect which everybody is doing and you are good in that. So then probably you will fall into that trap, and after certain years or certain simulation or certain periods, you are going to lose the market. And then obviously I'll go little deep on this, not very deep, just for the programming thing I am just going to mention that these are not very difficult to run. There is a package in Python, you can use it, Node2Vec, okay, and I don't know how many have used Node2Vec. Anybody use it? You use it. Probably you have done this kind of work, right? Yeah. So is Node2Vec in Python, you can do that, and typically if you see this graph, you can do the network graph analysis here, and dimension is embedding dimension is default 120. You can keep on changing. There is nothing called walk length is something that also it is kind of a you can have 80, 100 or something like that, and on that basis you can do that. But these are all simulation. You can try to do it where you can fit that your business context is getting validated, and probably you'll try to see that if I am using what is the optimum thing, what is the optimum value, and these kinds of algorithm, you cannot say that 80 is optimum or 100 is optimum. It keep on simulating the different values and try to match the output with your business context. That's the way you try to do that, and there is nothing called R square or any of the confusion matrix, something like that is not there, and that is the only problem whenever we are using this kind of model. And there are P is kind of a, if we consider that this BFS and DFS, P is your probability that whenever you are choosing the BFS, and Q is your DFS path, the depth of that path. So that's the way P and Q, and generally by default 1 whenever you don't want to influence the model. But if you want to influence the model and see that we want to work on more about the neighborhood structure, like we are in HSR and we will always influenced by the HSR community, then probably we need to keep some value P varied or Q varied on the basis of global, or you want to do a localized optimization of this whole thing. Exactly not optimization, but probably the influence you want to have in your model. That's the way you need to do. And then the wait key and wait you can do it, and workers, number of workers of the parallel execution and sampling strategy. But whenever we are using this kind of model, there is another thing obviously which comes into the picture, that context, and context is very fundamental of the whole thing. Like whenever we are in a room, we are very silent, and after going to the home, then we started enjoying because it's a Saturday evening. The context is that we are here silent and wanted to learn from each other, and that's the kind of a context we are having here. The context will change whenever we go back to party and other things. So it's a kind of a context I see more like environmental variable rather than global or neighborhood variable, because you are sitting in a pub, you will behave in a certain way. You are sitting here, you will behave in a certain way. It's like an environmental variable. You may not have to model directly in a graph, but you can model it like environmental variable, like the other are doing. I think Netflix started doing it, contextual modeling, very recently, and on that basis, the environmental modeling they are doing it. And if you go for the output purpose, output is very simple. If you see, you'll see that similarity matrix of one customer versus other, and also you will get product similarity matrix. I just put 0, 0, 0, you can put 1, 1, 1. And then if you can merge these two, you will get essentially the same way the collaborative filtering is. Okay. And since we always, as a modeler, we face the challenges that we have the stakeholders, and they always ask that how to validate the model. And we face this issue every time. I don't know anybody haven't faced this issue in my life. I haven't heard anything like that, right? Please raise the hand if anybody not faced this issue. People will say that I face the issue of understanding that people will say that I understand regression, don't teach me regression. Now tell me how we are going to get beta x. Okay. And probably the most difficult part is that they always know the regression, they will always try to get that how to validate the model, and they will ask the question to you. And that is the problem you are going to face is in graph embedding. And they cannot see what is happening, and this is little mathematical, and they will say that how do I know that this is going to be useful? So there is nothing called that way the model accuracy, and what we actually use that in a practical way whenever we have this graph embedding model ran, and then we started using it into the practical ground whenever we go to the market and see that this is the recommendation are coming, and how good the recommendations are or bad the recommendations are. Basically we are going to measure by recall, precision and rank ordering, and this is the way we are going to measure it. There is nothing we can do it in a programming stage, or nothing we can do mathematically, though we can twist all these parameters. Next time whenever we don't see this recall, precision and rank ordering, we will go back to our whiteboard and start twisting all these values. Maybe we will twist Q, P, and maybe that we can little bit increase the work length, because that will give us more robust result. But ultimately it's a more like a simulation, and go and test into the market that how good your understanding is or bad your understanding is. So that is the whole fundamental of this modeling exercise. It's not like a normal statistical model that we can easily get hold on it and easily implement, and that is a challenge that you will not often see that into the market, and it's difficult for convince the stakeholders, and that's the way that fate of it is. So further study you can go, there are Stanford University, you can go there, they are using it, and some of the picture I have taken from that, and some of the math site is there, you can probably go, and it is having the detail. You will have programming, you will have a data set, you have everything there. You can use it first time, and after that you can probably understand that into your business context. But fundamentally what is that you are capturing is that you are going to have going to capture the behavior of customer and products, because products also changing, right? whenever we started using it at childhood, the products we are using, we are not using today. So products are changing in their behavior and your customers are changing. All this changing behavior will capture and give you the final destination or future or predictive kind of behavior. That's the way graph embedding systems are. Hopefully I have not gone into too technical. And thanks. I think any questions?
Just one question.
Yes.
Will you try to do the analysis of generative AI?
Huh.
How you could actually do some recommendations for customers based on the changing market due to generative AI? I mean, I'm loud enough. Oh,
Okay. Sorry. Yeah.
So just wanted to know, like, whether you have done some kind of analysis on the generative AI perspectives using Node-to-Vector.
Yes, yes.
You did?
We are doing it.
Could you share?
I cannot share, that is confidential, but yeah, we are using it and it will be in the market. Okay, it started using it. So same kind of algorithm has been used. So that's why I don't think that but obviously we need a very strong person inside the company who will support this kind of algorithm.
I agree.
As vendor, it's very difficult. As consultant, it's very difficult. And you need that kind of guy inside the company who will actually sponsor you for that. Thanks, I think. Yes.
So what is the maximum data set you use for Node-to-Vector?
Currently, I think around 15,000 outlet customer behavior, you can use it. But see, it is also you have to see that how much global influence you wanted to have. If you want to work on the Bangalore market I am talking about, you may not have to go to Chennai market to understand the market.
So what we had observed is in Node-to-Vec, there was quite a bit of we can say deviation when the hyperparameters or data cleaning, and especially when you're going over large data sets, hundreds of thousands, even when we are going to proper 1 petabyte data.
See, you have to limit it to your variable set, because otherwise it's very memory consuming and difficult. It may not optimize also, you will not get any result.
So we can safely say that this is more of a marketing / strategist's tool rather than a full-fledged data analyst tool.
I bit differ because see, everything started with a strategy with a small data set. Whenever I first time, if you use any of the deep learning algorithm, you're right, or I think that that's the way the small data set we started using in everywhere. But whenever we have a large computation power like in Azure and everywhere, then probably we'll be able to use this. You cannot use it in normal laptop and normal. It's a cloud-based infrastructure you need to have, and we need to think about the optimization of the resources, because it's a resource intensive. You are right there.
So now that we have more complex and simpler and let's say lighter embeddings with the entire LLM advent, the way in which vectors are even envisioned and stored is now completely different. Do you think there's a different way to look at this altogether with that? So we had the way in which traversals and that random walk and
Correct.
Now that we have contexts and vectors that can correlate much simpler, do you think that's another look we should probably be
I think that yes, we can do that, but that will overcomplicate the whole structure. Because if you use the context, like today I am talking about that today we are very sunny day and beer sales will be less. Okay, people will not have beer, because if it's a cold day and it's a rainy day, people have beer. So that's the context, right? I'm talking about the global context, and it can be a smaller context that I have a fight with my wife and I want to have beer. That's a different context. Okay. So in a global context, if I just consider, then if I want to introduce that into this graph network, then you need to have all these instances into past to train certain samples. And typically we don't get that kind of data enriched, and I'm expecting that will happen long run. But yeah, your question is very valid, but I think that I'll rather do it in a different model and say that, okay, my context is different. I'll do a second order model, take the context and the graph separately. Otherwise it will be too complicated and to handle. Thanks. I think nice question. I think probably you used it. That's why you face this kind of issues, right? But I understand it's a not kind of a commonly used because of usage of the memory power and other part. But I think that people have started using it, and I say that obviously we need some sponsor inside who will support this kind of work, because essentially the question boils down to same thing: how do you validate it? Yeah.
Hi. Hello, sir.
Yes.
So I've just started working with graph networks. So one problem that I encountered is that when I created embeddings and then created a graph out of it, so what happened is that the results that I got from graph were not very different from the embedding similarity. So what I inferred through it was that maybe the embeddings are overpowering what the graph has to provide to the knowledge. So, I just wanted your thoughts on it. I got some solutions from ChatGPT to how to evaluate it, but eventually, I guess it will be difficult. And is there any way so that we rely more on so that the topic learns more from graph rather than the embeddings?
Yeah, I understand this phenomenon, and probably we face this phenomenon every of the modeling or simulation issues, right? Probably we have to go back and see that what are the variables we capture and what are the data set it is, and sometimes we go as rudimentally like the standard deviation, checking the standard deviation. Like everybody is getting the promotion and I want to do graph embedding, then it's not possible to do graph embedding on promotion taking into account, right? Because it's a common phenomenon for everybody, so I cannot do. So that's the way you need to go back. I think it has values, but probably we miss out the important attributes sometime, and you need to, if you can capture that, you will get that values. That's the whole read. I'm still learning, very honest. It's a very new topic. I'm still learning. I'm not the expert, but and obviously it's not widely used phenomenon that you will get lots of instances into the net, and obviously it's happening. So probably you need to see that way. That may help. But that's the only thing I can say, that probably you need to change the attributes, change the customer set, and you will get something there. Yes.
Recommended system, as I understood it, is mainly be applicable for the marketing strategy business. So do you think how I can correlate same recommending system across the different business areas or the business domain of the automotive sector?
See, I think first of all, one sorry to say that there is not in this the whole thing is that all the attributes we generally need to capture are orthogonal factors. There is nothing called correlation that way. Okay, if I say that if I don't consider the orthogonal factors, then I'll read the same thing again and again. Okay, that's the whole philosophy of graph embedding, that we need to capture the orthogonal sets. And in automobile also, what context you want to use it, that I need to know, because automobile has a manufacturing context, it has a marketing context, it has sales context, it has the different context. R&D. See, R&D, I don't know, I have not worked on the automobile R&D. I have little experience on the automobile marketing, where it can be used widely. But if I say that R&D, if I just consider that way, that whenever you are doing a design of the car, then probably it will be very useful. Because what is going to happen that suppose you want to have whether it is a leather handle you want to put in the car, and you want to know that who is going to buy, what set of the customers needs to buy, because ultimately R&D has to attach to your end goal of generating your revenue, which is marketing and sales.
At the end, it is mainly used for marketing strategy.
So you can have 5 attributes, but which one is going to make you successful into the market, then you need to use it, started from R&D. You may have a 5 concept built into that, and then you see that one concept is working, which you need to go in this graph embedding, because the whole thing is that you are changing the whole attribute set. Like EV, I am using it today. It was not there 5 years back. If I just use the average of that, I am the first buyer in my society, which is 200 housing society. So you will not get any behavior capture. Then probably you need to go by graph embedding. So that's the way it is. It's a very newly, our markets are changing. So that's the whole thing. Thanks. Nice question. Thanks everybody. I think it's a nice discussion.